Hi everyone. Today I'm going to talk about how to determine RS configuration. Before we do that, the first step we have to do is to find the chirality center. We can call it the stereo center. And what's the stereo center? Stereo center is a tetrahedral atom, usually carbon, that has four different substituents. It's important, like four different substituents. For example, right here I have the molecule right here. Before the the dash in west, right? The dash ones mean far away from you. The dash one right here mean far away from you, and the west mean toward you. And right now I have an example, which is the molecule right here, and how to determine how to find the chirality centers. Okay, right now we have four carbon right here. Oh, three carbon, one, two, three carbon over here. Check out the first one first. With the first one we have one, two, three, four different. I mean, not that one. Four different substituents right here. This is the whole. This is the whole substituents of the number one carbon. So for number one carbon, we have four different substituents. So number one is a chirality center. Is a stereo center. And how about number two? How about number two? How about number two? Number two right here is a what? It's a CH2. I'm gonna draw like this. It's a CH2. And how many subs does it have? One sub, two sub, three sub, and four sub. They have two different subs right here, but the two H right here, they are two same substituents. So it's number two carbon is not a stereo center. Check out number three carbon. Let's have one, two, three, and four different substituents. So number three is a stereo center. Step two, we assign all four different atoms, like four different substituents, attached to the stereo center a priority from number 4 to number 1, from number 1 to number 4, or from letter A to letter D, based on the atomic number. Be careful. Right here we compare the atomic number, not the molecular weight. The atomic number is like a priority, the higher priority, something like that. So I have the conclusion right here. Highest priority means largest atomic number, mean it is number 1. So I give you example, a molecule right here, and the right side right here, the yellow writing, I give you the atomic number of each element. Hydrogen is number 1, carbon has a priority 6, oxygen is 8, and bromine is 35. It's not the molecular weight, it's the priority, is atomic number. So look at this molecule. We have bromine, the biggest one, right? The largest atomic number is the number 1. So bromine is number 1. Bromine is the number 1. Hydrogen, number 2. What's the number 2? Oxygen is the number 2. It's right here. Number 3 is the carbon. Number 2, this is number 2. Number 3 carbon, and number 4 is a hydrogen, right? In step 3, if two identical elements, now if there are two identical elements that attach to the same stereo center, we have to go to the next element that attach to it, that attach to that element, then determine the total priority of that substituents. Okay, I'll give you this example. For example, right here, and what is the highest? What's the largest atomic number? What's the largest molecule element? Oxygen, right? So it's the number 1. And hydrogen units is number 4 because it's the smallest one. And for right here, see these two substituents right here, we don't know what's the number 2 or 3 yet, right? Because they are two identical elements because the carbon, they are both carbon. And the carbon right here, they connect to 3 hydrogen, 1, 2, 3 hydrogen. And the substituents on the right side right here, they connect to what? They connect to a carbon right here. They connect to our carbon and 2 hydrogen over here, right? 2 hydrogen over there. So this one have higher priority because it connect to carbon, hydrogen. This connect to hydrogen. This is 3. This carbon is 6 plus 1 is 8. So this one is the number 3. So still right here is the number 3. I mean number 2. Sorry, number 2, and this is number 3. See. Next goes to step 4. Next, we rotate the lowest priority using number 4. It means number 4. We rotate the number 4 away from U. Make it a dash. Then follow from number 1 to 2 to 3 to determine the RS configuration. Right here, I give you a determine RS, a definition RS. R means clockwise, S means counterclockwise. Yeah, in Roman writing is R means rectus and S means sinister. So R clockwise, S is counterclockwise. First, I'll give you an example right here. Okay, we all know that's the number 1. This is number 4. This is number 2. This is number 3, right? And we rotate the lowest priority, which means number 4, away from U. And how we rotate from U, I have a easy technique from my different video. You can click on the card on the top right corner, over there to see that technique. Right now, I'm gonna rotate it from my technique according to my technique. I'm gonna rotate the number 4 away from me. So I'm gonna rotate it away from me. How I rotate it? See, I'm gonna rotate it right here. From dash to where? From west to dash. H right here. H. C3 to H5. And now label it 1, 2, number 3. So go to and then we go from 1 to 2 to 3. 1 to 2 to 3. And L is a what? 1, 2, 3. We ignore number 4. 1, 2, 3. It's right here. 1, 2, 3 is a what? Is a counterclockwise, right? It's a counterclockwise, so it's a S. That's it. Thank you for watching. Check out the next video. Thank you.